Hi everyone, I'm Zilong from Indiana University Bloomington. Today, the title of my presentation is Demystifying Local Business Search Poisoning for Illicit Drug Promotion. First of all, let's look at these newly emerging drug promotions. In the past, many works have studied the online drug promotion. For example, some researchers have studied the drug selling on online anonymous marketplaces or social media like Twitter and Instagram. Researchers also find the promoters use various SEO methods to promote their business, like search redirection or promotional effects. With the development of search services, drug sellers also adjust their methods or strategies to promote their business. Today, we turn our eyes towards a new platform, local business search. With the development of the mobile internet, people tend to use the internet to find the business around them, like restaurants, pharmacies, or groceries. The business can be introduced by the local search services in the form of listings. The local business search including knowledge panels, map search, and voice search. Obviously, it is a good chance for drug sellers to promote their illicit business. So let's look at what happened in the local business search. When we type "buy research chemicals online medicine Wisconsin," Google returns these illicit listings in the knowledge panel. Similarly, on map or voice assistants, when we query with the same trigger, the services can also return the same illicit drug listings. So, the illicit listing successfully contaminates Google in different channels, and the drug sellers leverage Google to help them promote the illegal business. We call these illicit drug listings as idols. We believe it would have bad impacts on many search users. In our threat model, we consider that miscreants aim to pollute local search results with illicit drug promotion. They first publish the illicit listings from the upstream agents or brokers. Then, they let these listings flow from the agents or brokers to a downstream local search services. Here, the upstream brokers are the companies that specialize in collecting local business listings from various data sources and selling such information to third parties. The agents are the intermediary companies for local business owners to publish and maintain their listings on multiple brokers. Facing a problem brought by illicit drug listings, we tend to do something to understand and mitigate this threat. The first thing is to design a method to find out these illicit listings from the listing collections of the data owners. Then we need to understand the ecosystem of these listings and relieve their impacts on the common search users. In our work, we report the first systematic study on illicit drug promotion by poisoning local search results. Here, we will introduce our graph mining-based method for effectively and efficiently detecting illicit drug listing. Our method is based on the observation as shown in the table. Miscreants would post the idols on many brokers with different names, like Cretin Detroit or Cretin Columbus. But they may reuse part of the connected information, like the telephone number as shown in the table. So, can we leverage these characteristics to form a graph by connecting these nodes with their relationships in sharing information? Of course, the answer is yes. If two listings share the same connected information, like telephone number, we believe they are owned by the same promoter. This forms a strong relation, and we use the strong connected edge with a higher weight to represent this relation in the graph. Meanwhile, if two listings have the same drug or slam keywords or promotional terms in their information, we think they may have a similar promotion tendency and they may belong to the same category. We build the weak connection edge with a lower weight to represent this relationship. In this picture, the nodes represent a listing, the thick lines represent a strong connection, and the fine lines represent a weak connection. With the undirected weighted graph we extracted, we design the IDLL spreading algorithm for detecting. With the algorithm, we can use a small number of labeled listings to infer other unlabeled listings in the graph. Additionally, as we know, some drugs are not illicit in some areas, like marijuana in Denver. So we use the allow list or areas to identify the truly illicit listings. To get a broad view of the IDLL's impacts on the entire listing ecosystem, we further extended our detection results with the listing scanning services from Yext and find out whether the detected illicit listing exists in the 51 brokers partners of the scanning services. So to understand whether our method works, we evaluate our method. We crawled 94,000 listings from 8 data brokers with more than 1,800 drug and slang keywords. We manually label a small part of listings as ground truth. The detection results show our method is quite effective, and these discovered illicit listings would help us to do a large-scale study. Leverage the detected listing, we try to understand these listings and their impact. Here, we introduce some interesting findings. The left picture shows the amount of the detected illicit listings in 8 brokers. Infogroup, Metadata, and Yelp are the top 3 sources of our detected listings. In the view of drug, marijuana is the most popular drug in illicit listings, followed by CBD oil and research chemicals. The most interesting finding in our study is that the promoters leverage different strategies to deceive or reach more consumers. The first one is phishing. In our detected illicit listings, we find 34 phishing illicit listings located at the address of legal places like pharmacies or theme parks. For example, we found a list that has a similar URL as the real Walgreens pharmacy. Further studying this listing, we found that it also used the address of the legal pharmacy as its own address. With the popularity of the voice assistant like Siri and Google Assistant, many promoters use natural language questions as business names. This takes advantage of the fact that voice search users always use natural questions as queries on assistants. Question format business names can easily match the voice queries by assistants. To be introduced to more consumers by search services, especially the voice search, promoters add cities or nation names in business names. The example names in the slides even add 3 nation names, including United States, United Kingdom, and Australia. We further studied the illicit impact on the search environment. We searched for the detected illicit listings on different search engines channels, including voice, knowledge panels, and maps. The search queries are the business names or the generated natural language queries. In the voice search, we found more IDLLs can be detected from Google Assistant than Siri. About 15% of IDLLs can be encountered by more than one voice command. In web and mem search is more seriously affected by the IDLLs. Among the three mem searches, Bing memes have more IDLLs than others. To show the impact of such promotion on local business search, we also estimate the revenue of the business owners from the listing promotion. The owners can accumulate more than 400 buyers every year. This can lead to at least $480,000 earning every month. In the next, we will discover the illicit listings ecosystem. In the local listing ecosystem, agents, brokers, and search engines from the upstream and downstream relations. Agents help business owners promote the data to brokers and search engines, and brokers also package their data for search engines. If the vetting procedure of the agents and brokers are weak, it is easy for illicit listings to flow into the search engines. We investigate the two of the most popular agents, BrightLocal and MostLocal, and neither of them have contact restrictions. We also investigate some brokers. Similarly, none of them has content verification. In addition, local data distributed by agents can be shared to not only their partners, but also other brokers. For example, BrightLocal distributes the data to its partner LocalLeads. After getting the data, LocalLeads can distribute to its partners, but these partners may not be the partners of the BrightLocal. Such propagation would make the listing contamination much more serious. What have bad effects on the consumers is that the unverified listings can still be accessed by users. These listings may be signed by claim this listing or unclaim in different brokers like Localize or Google Maps. To check the illicit listing pollution in brokers, we search our detected illicit listing in 51 platforms. Facebook, Bing, and Yahoo are seriously affected by the detected listing in our results. To understand the sources of illicit listing in search engines, we checked their sources in Bing Map. We found that most illicit listings are from the Facebook and Foursquare. To mitigate this emerging threat, we also propose some strategies. First, agents and brokers should conduct more strict vetting on listings. Second, local search services should make efforts to vet the shared data from upstream and delete the poisoned search results. Finally, everyone in the ecosystem should unify their policies to disrupt this propagation. We further investigate the ecosystem outside the United States, including the United Kingdom, Canada, Brazil, and Germany. Different ecosystems share some similarities, but also have some differences. In conclusion, this work is the first systematic study of illicit drug listings on local search services. We propose the IDLLSpread algorithm to discover these drug listings. We further investigate the ecosystem of the drug listings and impact brought to the different users on different search channels. So, thank you very much for your attention and welcome for your questions.